Welcome to the Explainer. Today, we're going to talk about an AI that basically thinks like a detective. It can look at this massive, complicated puzzle with just a couple of clues, and somehow it figures out the entire picture. This is a really powerful technique, and it's quietly changing everything, from your email spam filter all the way to medical diagnoses. Okay, so to get our heads around this, let's start with a story. I want you to imagine a young explorer. Her name's Ava, and she has this dream of mapping the entire world. But she's got a huge problem. Most of the land is a total mystery. So at first, Ava tried hiring these expert guides to label every single thing on the landscape. Every path, every river, you name it. Now, in the AI world, this is what we call supervised learning. And yeah, the result is a perfect, super accurate map. But as you can probably guess, Ava figured out real quick that hiring an expert for every single step is painfully slow and crazy expensive. So she tried the complete opposite. She just went out there with no guide at all, just kind of clustering things together that looked similar. All the forests go in one group, all the deserts in another. This is like unsupervised learning. It's cheap, it's fast, but the map she ended up with was, well, it was often vague, pretty unreliable. A forest might have a hidden swamp in it, but she'd have no way of knowing. So Ava felt totally stuck. She's got this massive, mysterious land right in front of her, but no practical way to map it. One way's too expensive, the other's too inaccurate. She really needed a breakthrough. And then she has her big aha moment. Tucked away in her bag, she finds this small, old notebook. And inside, just a few key locations are perfectly labeled. A specific mountain peak, one particular river bend, and she thinks, wait a minute, what if I could use these few clues to figure out everything else? And that idea, that's the absolute heart of semi-supervised learning, or SSL for short. You take a tiny handful of really good labeled data, our known landmarks, and you combine it with a huge amount of unlabeled data, the rest of that mysterious map, to build out the complete picture. And this chart just brilliantly illustrates the real-world problem that SSL is built to solve. Getting perfectly labeled data like, say, a doctor identifying a tumor in an X-ray, that's rare, and it costs a lot of time and money. But unlabeled data, like every other X-ray in the hospital's database, it is absolutely everywhere. SSL is what helps us bridge that gap. So how did Ava actually use her few clues to map out all that unknown territory? Well, she came up with a set of really clever tools. And these tools, they're really just intuitive assumptions. And they happen to be the very same assumptions that power modern SSL algorithms today. Ava's first tool was pretty simple. When she'd look at an unlabeled spot on her map and was, let's say, 99% sure it was a forest because it was right next to another forest she already knew about, she'd go ahead and tentatively label it forest and just add it to her list of known places. In AI, we call this self-training. The model makes a prediction, and if it's super confident about it, it just treats that prediction as a new piece of truth to learn from. I mean, the model literally teaches itself. The only danger, of course, is if the model is confidently wrong, it can start reinforcing its own mistakes. Next up, Ava started noticing that all these unlabeled spots on her map seem to naturally huddle together in these little groups or clusters. And usually a few of her known labeled spots were sitting right there in the middle of these huddles. This visualization shows the idea perfectly. It's called the cluster assumption, and the logic behind it is just common sense. If an unlabeled point is hanging out with a big group of known blue points, it's probably blue too. The model learns to draw its boundaries in the empty spaces between the clusters, not right through the middle of them. Now, Ava wasn't working alone. Her friend Ben was also a mapper, but he had a completely different way of doing things. Ava mapped based on what she could see, the terrain. Ben mapped based on what he could hear, local stories and travel logs. So they each had a totally different view of the exact same world. This is a really powerful SSL technique called co-training. What you do is you train two different models on two separate sets of features. So for a website, one model could look at the actual text, while the other looks at all the hyperlinks pointing to it. Then they start labeling data for each other, combining their unique perspectives to get to a much stronger answer. Finally, Ava developed her most advanced technique. To truly understand a place, she learned to deconstruct it into its basic features, soil, rock, vegetation, and then reconstruct it. In AI, this is a lot like something called a ladder network. The network takes in some messy, noisy data, boils it down to a simpler form, and then tries to reconstruct the original clean version. By getting really good at this reconstruction game, the AI develops a much deeper understanding of the data's fundamental structure. Look, Ava's mapping journey isn't just a fun story. It is a direct analogy for how some of the most powerful and practical AI systems all around us actually work. SSL is the hidden engine behind so much of our modern tech. Just think about your email. You mark a few emails as spam, and bam, the system learns from those clues to filter thousands of other unlabeled emails. It's used by doctors to help find diseases in medical scans. It's used by voice assistants to understand what you're saying. It's everywhere. This quote really just says it all perfectly. We are swimming in a sea of unlabeled data. Photos, texts, audio recordings, you name it. SSL gives us the key to unlock all the valuable information that's hidden inside, without needing a human to sit there and label every single little piece. Now, to really appreciate SSL's role, it helps to kind of zoom out and see where it fits inside the bigger family of AI learning strategies. This table lays it out nice and clear. Supervised learning, that's like studying with a full answer key. Unsupervised is like being handed a library of books with no titles and being told to sort them. SSL, though, hits that sweet spot right in the middle, learning from just a few clues. And you'll see self-supervised learning on there too, which is kind of like SSL's cousin. That's where the AI cleverly creates its own labels from the data, like taking a sentence, removing a word, and training itself to predict what's missing. It's just another smart way to learn without needing humans. All right, so let's recap the 3 big takeaways here. First, SSL is all about that smart mix, a little bit of labeled data and a whole lot of unlabeled data. Second, it works because it relies on these common sense assumptions, like things in the same cluster are probably the same, to fill in all the blanks. And third, this very practical approach is what makes powerful AI actually possible in the real world, where perfect data is a total luxury. And this kind of leaves us with a final thought to chew on. We live in a world that is just overflowing with unlabeled, unstructured information. In a world like that, maybe the future of intelligence, both for humans and for AI, isn't about having all the answers memorized. Maybe it's about having the skill to learn from just a few good clues.